Hi everyone, welcome to Medicine YouTube channel. In this video we are going to see about the first line of drug, which is known as antitubercular drug. We have already uploaded a video on tuberculosis. Please do watch it. In that doesn't teach about the management of the tuberculosis. I am teaching here, which is the first line of antituberculosis drug. The first line of antitubercular drugs are Isoniazid, Rifampicin, Pyrazinamide, Ethambutol and Streptomycin. These are the 5 drugs which are the first line of antitubercular drug. And these drugs have high antitubercular efficacy. It has antitubercular efficacy, high antitubercular efficacy as well as low toxicity, and it can be used routinely. The Isoniazid. Now we will see one by one of the antitubercular drug. The first one is Isoniazid. It is the first line of antitubercular drug. It acts as extracellular as well as in intracellular. It acts both the cells in outside of the cell as well as the inside of the cells, and it is effective in both the medium, which is alkaline as well as acidic medium. The Isoniazid is completely absorbed orally and penetrates into the body tissue and placenta. It completely absorbs in the oral cavity and penetrates into the body tissue as well as the placenta. The most possible action of the isoniazid is inhibition and the synthesis of the mycolic acid, which is a unique fatty acid component of the mycobacterial cell wall. In the mycobacterial cell wall, there will be a unique acid which is known as mycolic acid, which this synthesis is inhibited by this isoniazid, so that the cell wall doesn't get properly made for the bacteria. And it is extensively metabolized in the liver by acetylation. This isoniazid is extensively metabolized by acetylation and metabolized and excreted by the acetylation. Now we will see the second line of drug, which is Rifampicin. Rifampicin is a bactericidal drug of the Mycobacterium tuberculosis. It is the best bactericidal drug which is of the Mycobacterium tuberculosis. Rifampicin inhibit DNA dependent RNA synthesis. The major function of this rifampicin is it inhibits the DNA dependent and RNA synthesis, and it is well absorbed orally, widely and distributed in the body and penetrates into the cavity, placenta, meninges, and it is metabolized in the liver by and excreted in the urine and bile. This is the rifampicin. Now this is the second drug which is absorbed. It inhibits the DNA dependent RNA synthesis. Now pyrazinamide. It is a more active in acidic medium. It is more lethal to intracellularly located bacilli and to those sites showing inflammatory response. It is a more active acidic medium. It is more active in acidic medium. This pyrazinamide is active in acidic medium and more lethal to the intracellular located bacilli, which is present in the inside. As well as in that side there will be inflammatory response. The pyrazinamide is orally absorbed, widely distributed by penetrating into the CSF, extensively metabolized in the liver and excreted in the urine. Now the next drug is Ethambutol. It is a selectively tuberculostatic, clinically active in fast multiplying. It is a selectively tuberculostatic. It stops the activity of the tuberculosis. So it is tuberostatic, as well as is clinically active in the fast multiplying bacilli. When the bacilli gets fastly multiplied, in that area these are clinically active and more susceptible and atypical mycobacteria. The patient acceptably is good and the side effects are low. Now the Streptomycin. This is the last drug in the first line of antituberculosis drug, and it is first clinically useful tubercular drug. This is the first as well as clinically useful tubercular drug. It penetrates into the tubercular cavities but does not crosses CSF. It penetrates to all the tubercular cavities but does not cross CSF. But in Ethambutol as well as pyrazinamide, these cross CSF and has poor action in acidic medium. It has poor action in acidic medium. Resistance is developed rapidly when the streptomycin is used along the tuberculosis in more patient has relapsed. When this streptomycin is alone used, the tuberculosis shows resistance to this streptomycin. So we should not use the streptomycin alone, and it has poor action in acidic medium, and it does not causes the CSF. That's all of the streptomycin. Thank you. If you like this video, please do like, share and subscribe my YouTube channel. If you have any doubt on it, please do comment it. If you want more videos, please do subscribe. For notes, please do follow my Instagram page. I will provide the link in the description box. I will provide these notes there. Thank you.